Hey everybody, welcome to Lesson 5.3, Adding and Subtracting Rational Expressions, Part 1 and 2. Okay, so we're still using that same Common Core standard. Can you add, subtract, multiply, and divide rational expressions, and that they're closed under each of those operations, meaning if I add two rational expressions, I get a rational expression. That's what that idea of closed means. So today's objective, we're going to add or subtract rational expressions, and they're either going to have a common denominator or they're going to have a uncommon denominator, and we're going to have to do some more work. So I've highlighted here, adding and subtracting rational expressions is similar to adding and subtracting fractions. Okay, you need a common denominator. So when the denominators are equal, let's go ahead and get started. I've just got two quick examples. Okay, so we have 3x minus 4 over x plus 3 plus 2x plus 5 over x plus 3. So with fractions, when they have the same denominator, you're just going to go ahead and leave that denominator. You're going to just say, okay, the common denominator is x plus 3. You're not going to add them together, okay? And in this case, the numerators, or you're not going to do anything with the numerators. They're just going to come down. You're going to have 3x minus 4. That's in the first rational expression, plus, so that plus sign there, that plus, and then we're going to bring the 2x plus 5 down, the 2x plus 5. From here, you're going to combine like terms. So I'm going to look at, so 3x and 2x are my common terms, so that gives me 5x's. Okay, and then I have negative 4 plus 5, which gives me plus 1, all over x plus 3. Okay, so we had to simplify by adding those. So it's very similar to adding fractions. Now, the only thing x can't be here is x cannot be negative 3. Okay? So that's that completed problem. Make sure that you put any domain restrictions back from the original. So our second one here, you really have to pay attention to the subtraction sign. Okay, so notice how the denominator here is x squared plus 2. Okay, so that's going to be our common denominator because they both have the exact same thing. So x squared plus 2 just gets written. Okay, I'm going to go ahead and write the first expression like I did in part 1, 2x minus 1. That doesn't get changed. However, here's where you got to be really careful. You have to subtract off 4x plus 4. You can't just put the subtraction sign with the 4x. That's really important. So I wrote that in red here for you. Okay, so now we're going to do the same thing we did in the previous problem. We're going to first distribute that negative, so we're going to have 2x minus 1, that stays, and that subtraction sign needs to be distributed through. Okay, so the opposite of 4x is minus 4x, and the opposite of adding 4 is subtracting 4. Okay, and then we get an x squared plus 2 in the denominator. We don't do anything with the denominator anymore. Okay, so the last little thing is to clean up the numerator. You got to add like terms. Notice I have 2x's and I'm taking away 4, so that's negative 2x's. And then I have negative 1 minus 4 more, which is negative 5. Okay, so there's nothing common between 2 and 5 other than 1, so we're going to leave that, so we get x squared plus 2. Now, look at your denominator, x squared plus 2. That graph, this denominator is never going to equal 0. Okay, if you think about the graph of that, it actually looks something like this. It's going to come down. Here's your parabola. It's never going to cross the x-axis. There's nothing that makes the denominator 0, so this is your final answer. So that's how to add and subtract rational expressions when you have a common denominator. Video 2 will go a step further when we have an uncommon denominator.